So more completing the square.
Okay, those sound like ones you can verbalize.
Yeah, so x squared.
Hold on 1 minute, let me.
Okay.
All right.
Minus 4x minus 37 equals, equals 2, actually.
Equals 2.
Yeah.
Wow, they did change it up.
Yeah.
Okay. Now, normally, if they had not given you the instructions to solve this by completing the square, you might think that you might be able to factor it. Because that's always easier than completing the square. So if I was going to try to factor it, I would move the 2 over.
Yep.
Like that. And now I would try to find factors of 39 that subtract to the number 4. Well, what are factors of 39?
1 and 39. You can't do 2. So 3 and 13. And that's it.
Yeah, those are both prime numbers, so we know we can't go any more than that.
Yeah.
13 and 3 subtract to 4.
No.
Okay, that means we cannot factor it.
Okay.
So we have 2 choices. We can either plug it into the quadratic formula, or we can complete the square. Now, if either one is acceptable, do you know the quadratic?
Yeah.
But the instructions say complete the square, right?
Uh-huh.
Okay. So when we're going to complete the square, we want to put the number on the other side. Like that.
Okay.
Only when you're going to complete the square do you do this. If you're going to factor it or use the quadratic, you want to leave everything on one side. Okay. Now, to complete the square, put parentheses and leave some space right there. Because completing the square involves adding another number. So, how to complete the square?
Would it be half of 4 squared?
Yeah. And it's always plus. Always.
Yes.
Never is it minus. Because even if it's a negative number, when you square it, it turns plus.
And then you plus 4 the other side.
Yeah, you have to balance. In other words, this line is now exactly the same as that line. The difference is that I can now write this differently. How can I write this trinomial?
You do x minus 2 squared.
Perfect. Combine those two numbers.
43.
Next step.
Then you do square root both sides, so it'd be x minus 2 equals root 43.
Whenever you take the square root of both sides of an equation, the first words out of your mouth should be plus and minus.
Yeah.
I don't know any other way to explain that. It probably is the most common mistake made in algebra, is leaving out the plus and minus. So the only way I know how to tell students is whenever you are taking the square root of both sides, which is what we did there, always, always, always begin your answer with those 2 words.
Yeah.
What's the rest of it?
So root 43, which
makes x equal to?
negative 2 plus or minus root 43.
Okay. It says negative 2 on that side. If I am moving that -2 to the other side, I've got to change its sign.
So do +2.
Now, that might be a final answer, and that incidentally is two answers. It's x equals 2 plus root 43, and it's x equal 2 minus root 43. So here really are the two answers.
Right.
Is root 43 simplifiable?
No.
No, it's a prime number. So there's no way I'm finding any factors of 43, let alone a factor that is a perfect square number.
Yeah.
So that's your final answer. Or this down here is fine.
Right.
That's what that means. But it is important to realize that when you have a plus or minus, one answer is the plus, the other answer is the minus.
Mm-hmm.
Now, could you have done this problem another way? Yes. Starting from right there, the moment you realize that you can't do it factoring,
And you could do quadratic formula.
yeah, you could just plug it into the quadratic formula. And notice that when you use the quadratic formula, you always get answers that look like that.
Yep.
So completing the square, believe it or not, the quadratic formula is derived by completing the square. I'm just going to say this real quickly. If I start with that,
Okay.
and I want to complete the square, first thing I'm going to do is this. I'm just going to take you through this real quick. Doesn't really matter if you don't understand it. With me?
Kind of.
In other words, well, just make sure you don't change any line. In other words, that line is the same as that line, correct?
Right.
Okay. Now, in order to complete the square, I've got to get rid of the a. So I factor it out.
Okay.
So I have a times x squared plus b over a x. See where that side is equal to that side? Okay. Didn't do anything to the right side, so it's that. Now, I should divide both sides by a. So I get x squared plus b over a x equals minus c over a. Now I complete the square on that side, because you always complete the square where you have the x squared and the x. I do it by dividing that by 2.
And squaring it.
So now I get x squared plus b over ax plus b squared over 2a squared equals minus c over a.
Okay.
If you complete this process, which is another 3 or 4 steps, you get the quadratic formula.
Really?
Yep, that's how the quadratic formula was derived. In fact, I like watching poker on TV, and there was a poker player that had a PhD in math, and somebody asked him at the table, do you know the quadratic formula? And he said, no, I do not know it, because I know how to figure it out. You can always figure it out using this method right here, by completing the square on the standard format of a quadratic. And you will end up getting x equals minus b plus or minus square root of b squared minus 4ac all over 2a. That's where that leads to, is that answer.
That's cool.
Yeah, it is actually really cool. If you actually go through that proof, or not proof, but solution, and see that that is what you end up with, it's It's cool. It's really cool that you can solve the quadratic formula by yourself, just starting with that and completing the square. But you have to use every single step that completing the square involves.
Right.
Okay, so what else do you have?
There is a totally different kind of problem. Like you have an equation you're solving for a variable. Like, okay. So, like, A equals 1/2 h in parentheses A plus B. And the first A is capital. And then we're solving for the capital A.
Okay. So the little a is different than the capital A, correct?
Yeah.
Okay. What's the first step in solving any equation? When you are looking at parentheses or denominators, what are you trying to get rid of? Both. You want to get rid of denominators and you want to get rid of parentheses.
Okay.
Let's get rid of the denominator first. What's our denominator?
2.
Okay, how do we get rid of it?
You multiply by 2.
Is that a B or a 6? That's a B, right?
Yeah, that's a B.
Okay, no more denominators. What's the next thing we want to get rid of?
Parentheses.
Okay, get rid of those.
Did you do HA plus HB?
What are we solving for?
Capital A.
What do we got to get rid of?
The H.
And the B.
So,
Let's get rid of the HB first.
minus.
Always better to get rid of whatever is being subtracted or added. The HB is being added. Let's get rid of that. That's real easy.
So then 2A minus HB equals H capital A.
Now
And then you divide it by H.
Here's your answer. Now, can we simplify that? We got 2A minus HB over H. That's actually a very acceptable answer.
Could you get rid of the H's?
There's only one H, so you can't.
Okay.
What you can do is turn this into two fractions. There's that fraction and there's that fraction. What's the first fraction?
First fraction is 2A over H.
It's the second fraction.
H over H. Or H.
HB over H, which is what?
Just B.
Okay. So that's another acceptable answer. Is the second one better than the first? No, not really. The first answer is perfectly fine. You don't need to split it up into two fractions like we did. Okay? So that's your answer right there. If it's a multiple choice, then you might see that answer. So you have to be aware that you could be looking at a simplified version or the original version.
Okay.
And both of those that I have circled are correct. It's all equal to capital A. And when they use a little a and a capital A, there is no relationship between the two. They could just have used A and Z. Okay, so just because they use a little a and a capital A, that does not mean anything. That capital A and little a are completely
They're different.
They're not related.
Right.
What else you got?
S equals C over 1 minus R.
Like that?
Yeah.
And they want to solve for R. Let me guess.
Yes.
Yeah. Because it'd be simple to solve for C, right?
Yeah.
Yeah, you just multiply both sides by 1 minus R and you'd have the solution. The only difficulty is solving for R. How do I solve for R?
Would you get rid of the
Get
1?
rid of denominators. The first 3 rules I use in solving equations are get rid of the exponent, get rid of the denominators, get rid of the parentheses.
Parentheses.
Well, we got a denominator here. How do we get rid of it?
Could you multiply both halves by 1 plus R?
No, 1 minus R.
Eh.
In other words, I want to multiply both sides by that, right?
Okay.
In other words, I want to multiply whatever gets rid of that. That's what I'm trying to get rid of, is the 1 minus R. That's the denominator. In order to get rid of it, I got to multiply it by the same thing.
Okay.
Now what?
Then
The next thing to get rid of. We got rid of our denominators. What else should we get rid of?
parentheses.
Okay. Distribute that S.
S minus SR equals C.
Okay. Now we're trying to solve for R. What do we got to get rid of first?
The addition or subtraction.
Okay. The first S. That one.
Yeah.
In other words, always get rid of whatever is being added or subtracted. So now what do we have?
Now you have negative SR equals S minus C.
No, C minus S.
My bad.
That's different. C minus S is not the same thing as S minus
S minus C.
Okay? So you cannot mix those up. Okay, now we're still trying to solve for R. So what do we have to do now?
So you divide by negative S.
Okay, what is that?
So R equals C minus S over negative S.
That's the answer. Now, let's look at that answer. Can I make that simpler?
Yes.
How?
You could split it into 2 fractions.
Okay.
So C over negative S and negative S over negative S.
Which is?
1
Plus 1.
plus 1. Yeah.
Okay. Now, that is really not any better than that.
Okay.
Okay? Which means you can stop when you get there.
Okay.
C minus S over minus S is just as good as this.
Okay.
Unless it's a multiple choice test, in which case you may only have that answer right. So you do have to be aware of the fact that this is the same as that. Because do you get multiple choice tests?
It might be one of
Or are all your tests you have to show your work and provide an answer?
Yeah.
If that's the case, then that's a place to stop right there. Because this doesn't really simplify it to any great degree. It just changes it. And there is a subtle difference between changing it and simplifying it.
right.
If I had something like this, Can I simplify that?
Yes.
How?
This would be 2c over 2.
Simplify.
And so that should be c. And then the other fraction would be negative 4s over 2, which would be negative 2s.
That is simplified over that. So it's important to know what consists of simplification. If I can reduce the numbers, which I did here, from 2, 4 over 2 to 1 and 2, then do it. But if I'm merely splitting it into two fractions, don't do it. Maybe if we do another one, I can make that clearer. Hold on. Computer is not being cooperative tonight. All right.
That's fine.
What else you got?
Okay. A equals 2LW.
Hold on 1 second. Let me try redoing this. Sometimes my drawing tablet doesn't work real well, and I need to restart it. Let's try that and see if it helps. All right, what you get? What do you have?
Okay. A equals 2LW plus 2LH plus 2WH. And then we're solving for H.
Okay. Let me close this out, unplug my drawing tablet, plug it back in. And that sometimes helps solve this problem. Yeah. It's so dark in here, I can't figure out how to replug it back in. There we go. Give me that again. Oh, hold on 1 second. What was it again?
Okay. A equals 2LW plus 2LH plus 2WH.
All right. If we are solving for H, what is the first thing we want to get rid of on the right side?
Pluses and minuses.
No. Which terms do not have H in them?
2LW and
move that to the other side. In other words, the only thing we want to stay on the right side of the equation is all terms that have H.
okay. So then equals.
Hope you can read this. Sorry.
Yeah.
Okay, now, because we're trying to solve for H, what are we going to do for the right side?
I'd start by dividing both sides by 2.
No, well, no, not really. You're trying to isolate H. Think that way. How can you isolate H on the right side of this equation? There are no H's on the left side. So if we can isolate H, we can solve for H. Well, how do you isolate H on the right?
You take out all the other.
Just factor out an H.
Ah.
What's left?
2L plus 2w.
Okay. Now we got h all by itself. On the left side, we still have that.
Mm-hmm.
How do we solve for h?
Would you divide by 2l plus w?
Yeah, whatever the coefficient of h is. So it's 2l plus 2w. That's the answer. And the way you can tell is if you have h all by itself on one side and you don't have any h's on the other side. You have solved for h. If you have h by itself on one side and you still have h's on the other side, you have not solved for h. That is h. It's equal to a minus 2lw all over 2l plus 2w. Now, I'm still having this problem. Let me try solving.
I can still read it.
Well, I know. Let me see if I can solve it completely by starting over here. It's getting to be kind of problematic. Not sure what I'm going to do about it. All right, let's try a new one and see if that works. Hold on 1 second. I got to do this part.
That's fine.
Okay, give me another one.
Okay. 1 over r.
Wow.
Equals 1 over r1.
R sub 1?
Yeah.
Okay, that's how you talk about subscripts. Is you say sub 1. That means R1 is completely different than R.
Yeah.
Could be just as soon, it could be A or B.
Okay. And then plus 1 over r sub 2.
Okay? What are you trying to solve for?
R sub 1.
Okay? So I'm trying to solve for that. So what's the first step?
You get rid of denominators.
Well, we want to get rid of all of this, right?
Oh. Okay. So you just minus.
Yeah. So I get 1 over r minus what?
1 over r sub 2.
And that's equal 1 over r sub 1.
R sub 1.
Okay. Now, if I am trying to solve for r sub 1,
now you get rid of the denominator.
well, okay, how can I get rid of the denominator on the right?
You multiply it by r sub 1.
Okay, so that gives us, let me write it in a different color, just to distinguish it. So if I multiply, oh man, this is really hard. Wow, I'm not quite sure how to fix this even. So, Now let me try. My problem is my drawing tablet. I don't know if you can tell or not, but whenever I put my cursor over the tablet, it starts writing instead of on the tablet. Let's see. What can I do here? So tell me what I get when I multiply both sides of the equation by r sub 1.
You just get r sub 1.
No? What do you get on the left side?
R minus.
Sub 1 all over R. Remember that there's no relationship between R sub 1, and R sub 2. Might as well be different variables. So multiply both sides of the equation by R sub 1. Hold on, I'm going to erase some stuff here to see if I can write this correctly. My computer may need rebooting before I can do this. Looks like it's going to. This is not behaving well at all. Hold on. So, take the bottom equation in red and multiply both sides by R sub 1.
So then that would be R.
Multiply the left side by R sub 1. What do you get? In other words, do this. Hold on. God. It's really tough when your computer isn't cooperating. Here, can I rewrite this? I got one. No, it's really screwed up here. So here's what I got. I got 1. Hold on, Jessica. Let me see if I can fix this.
This is the last problem.
This might work a little better. I don't know. So here's what I got. I don't have anything. So I had 1. Okay, now I'm in business. 1 over R plus 1 over R sub 2 equals 1 over R sub 1, correct? Is that what we started with? And we're trying to solve for R sub 1. So let's start by trying to get rid of denominators. So get rid of that denominator.
Multiply both sides by R sub 1.
Okay, so that gives us R sub 1 over R plus R sub 1 over R sub
R2
equals 1. We're still trying to solve for that.
Right. So then.
Well, we're trying to solve for R sub 1, correct?
Yes.
So what if we factor out an R sub 1 so that we have R sub 1 times 1 over R plus 1 over R sub 2. Is that the same thing?
Yes.
Okay. Now how do we solve for R sub 1?
You divide both sides by what's in the parentheses.
Yeah. So you got, I'm not sure I can fix this, Jessica, but I think you get the message.
Yeah.
In other words, R sub 1 is going to be equal to 1 divided by 1 over R plus 2
plus 1
over R sub 2.
Yeah.
Now, that's not the final simplified version.
Would you have to split it into 2 fractions?
Well, it's in 2 fractions now. You'd have to combine those 2 fractions. And I'm not sure you necessarily would. It depends on whether it's multiple choice or you're giving the answer. If you're giving the answer, you don't have to combine them. You'd get R equals 1 over r sub 1 plus 1 over r sub 2 or something like that. My problem is I've lost the original problem. I don't know. I don't think that's correct, actually.
No, it's r sub 1 equals.
How about r? That's what we're solving for.
And we're solving for r sub 1.
Oh, we are?
Yeah. It says
Yeah.
r sub 1 equals 1 over 1 plus r plus 2 over r sub 2.
Okay. That's an acceptable answer.
Okay.
Not quite sure how we got there, but do you have answers on these?
What?
Do you have answers to these problems?
Not for even numbers, which this was.
Okay, but you have answers for odd numbers?
Yeah.
All right. Let's see if things are working here. You have another one? Hold on.
Yeah.
Hold on, I gotta turn my writing tablet on. Wow, I don't know what the problem is here, and furthermore, I'm not sure I know how to fix it. No, it's pretty scary. I may have to go out and buy a new drawing tablet. What do you have for starters here?
Well, we do t equals d plus pm.
Wow, I have no idea why it's drawing it like this. It does seem to have fixed the problem, but okay.
And then we're solving for p.
Okay, so we're solving for that.
Yeah.
So what do we got to get rid of?
You have to get rid of
And in what order?
I get rid of the d first and do t minus.
Get rid of anything that's being added or subtracted first. So what's the next line?
T minus d equals pn.
And now what do we have to get rid of?
The n, so you divide by n.
Here's your answer.
That was pretty simple.
Yeah.
Okay. I have one harder one.
Okay.
1 over p plus 1 over q equals 1 over f.
And you're solving for s.
Yes.
It's the first step.
Would you get rid of the 1 on top of s?
Yeah, get rid of denominators. But better yet, we want the final answer to say s equals something, right?
Yeah.
So what's a better thing to multiply both sides of the equations by?
S.
Okay, we'll start with s. I was thinking s squared, but actually that's no help. So let's start with s. What do you get?
So you multiply both sides by s, it'd be s over p plus s over q equals s.
No.
Equals 1.
Okay. Now we're trying to solve for s.
So would you still get rid of the denominators?
Think factoring.
You could take out an s.
Okay. What's left when you take out an s?
1 over p and 1 over q plus 1 over q
No.
equals
Oh, right. 1 over q equals 1. In other words, I didn't do anything to the right side of the equation. I just
You just
factored out an s.
right.
So,
then
up here on the right, I'm going to have s equals what?
s equals 1 over p plus 1 over q.
Now, the problem with that answer, that's a perfectly fine answer. It's just not really simplified. In other words, we have to add the two bottom fractions together. Well, what do you get when you add 1 over p plus 1 over q?
1 over pq.
Nope. Got to come up with a common denominator, least common denominator when you're adding fractions.
Would be
You got here, let's draw it like that. What is that equal to? First of all, what's the common denominator?
pq.
So let's do this. That's always the way I do these. Now, what goes in the numerator at the top left?
Q.
Yeah. So you just want to make sure that that is the same as what's above it. What goes in the numerator at the top right?
P.
What's that equal to?
1.
What's that equal to? Q over PQ plus P over PQ.
Is just 1 because then
when you have a common denominator, the only thing you're operating on is the numerator if you're adding or subtracting.
Oh.
If you're multiplying, you're going to multiply numerators and multiply denominators. But we're not adding. We're not multiplying. We're adding. So it's add the numerators.
Q plus P.
All over the common denominator.
PQ.
Okay. So that's what that is equal to. The difference is that now we have a single rational quotient. What we had before was two terms, 1 over p plus 1 over q. You can't do much with that. But once you get that into q plus p over pq, you can flip dot, what's it called? Copy dot flip.
Not flip.
So what do you end up with?
So it'd be 1 over 1 times PQ over Q plus P.
That's the answer. PQ over Q plus P. That's what you get. When you do a copy dot flip of that, or excuse me, of this, you get PQ over Q plus P. And that's the answer. It's the same as 1 over P plus 1 over Q, but this is, whenever you have two terms in your denominator, never a good thing. You always want to add those fractions and simplify.
Right.
Okay. I have no idea how to solve this problem other than reboot my whole computer.
I think that's the last problem, actually.
Okay, good. Let's try. See if I can get through one more.
Okay.
Or was that it?
That could be it, because all the other ones are a lot easier.
Well, we've still got 10 minutes if you want. Let's do an easy one.
Okay. V equals 1/3 BH. So it's the formula for the volume of a cone.
Oh, BH.
Yeah.
Okay.
And then we're solving for B.
Okay. means you got to get rid of everything that's not b on that side of the equation.
Yep.
First thing to get rid of.
I do the h.
Do the numbers, always.
Okay. So then divide by 1/3.
Now, how about multiply by 3?
Right.
It's the same as divide by 1/3. But notice that BH is being divided by 3. So you want to do the opposite. You want to multiply by 3.
Right.
In other words, this is the same thing as BH over 3. So if we're trying to get rid of a divisor, let's multiply by 3. So that gives you 3v equals BH. We're solving for B, so what are we going to do next?
Divide by h.
There's your answer.
Yep.
In other words, whenever you're solving an equation for a variable, just got to get rid of everything else. The only variable is right there, so we got to get rid of that, and we got to get rid of that. Always do the numbers first.
Okay.
What else, Jessica? Anything?
C equals 2 pi r, but that one's pretty simple.
Well, let's do it.
We're solving for r.
Okay, what's r equal to?
So r equals c over 2 pi.
That's the answer.
Yep. That's about it.
Okay. Well, I can let you go.
Thank you.
I apologize for my drawing tablet problems. Not quite sure what I'm going to do about that. I hope I don't have to go out and buy a new drawing tablet. But
Yeah, me too.
anyway, you good to go?
Yeah.
Okay. We'll talk to you later. I guess I'll hopefully talk to you and Joseph later.
Yeah.
All right. Have a good night.
You too.